Okay, 700 joules of work is done to pull a stubborn dog, Cujo, across the ground. If Cujo has a mass of 55 kilograms, is initially at rest, what is his final velocity? Gotta watch out for Cujo. Before he bites your throat out. Okay? All right. So, things that we know in this problem. So, we know how much work is done. We know that he has a mass of 55 kilograms. He's initially at rest, and we want to find his final velocity. So 55 kilograms for the mass. Final velocity is unknown. Initial velocity is 0. Okay, so first things first, we need to figure out an equation. Now we've got our knowns and unknowns, we need an equation for this. So I'm going to look through my list of equations, and the key thing for me when I'm looking at this, because we got a ton of equations with V, we got a ton of equations with mass, we don't have a ton of equations with work. In fact, we've only got 3. We got W equals FD. We get P equals W over T, which that one's only for power. So there's nothing about power in this, so I can just ignore that one. And then we got work equals change in energy. Okay, so you have to ask yourself, what is this type of problem? Is this a work force distance problem, or is this a work energy change problem? Okay, so it doesn't talk about force. It does talk about pulling in, but it doesn't say what the force is or really explain the force. And it does talk about velocity change, which velocity change has to do with energy, kinetic energy specifically, motion energy. Okay, so I'm looking at this and I'm thinking it's this one. W equals change in energy, which change in energy, again, as we mentioned, kinetic final plus potential final, minus kinetic initial plus potential initial. Okay, so this is talking about pulling Cujo. So this is motion stuff. It doesn't say anything about stored energy, doesn't say anything about potential energy. Cujo's not going up a mountain. Okay, he's just getting pulled across the ground. So that means you do not need to worry about potential energy. You can just cross out the potential energies. There's nothing to be done about it. So now we just got the work equals the final kinetic energy minus the initial kinetic energy. So the problem told me he started at rest. So if he started at rest, I don't need to worry about the initial kinetic energy. So it's just kinetic energy final equals work. So W equals 1/2 mv squared. And the W is 700. So half of 55 is, what, 22.5? Nope. 26.5, 27.5, 27.5. Ugh, it's almost the end of the school year. Even my mental math is failing me. So 27.5. Divide that to the other side. So 700 divided by 27.5 gives me 25.45 equals V squared. Now I don't want V squared, I want just V, so I got to square root both sides. And when I do that, get 5.0 meters per second. So again, with these energy problems, you just want to think about, is it work or is it energy? If it's energy, it's talking about motion change or height change or something along those lines. If it's work, just work, then it's just talking about force and distance. But you can almost, not always, but you can almost always use this one, this work equals change in energy. Almost always can you use that one.